here's what we got. These are primarily the two types of heads that we're probably going to work with, okay? Now, I know some of you got some small block Chevys, and there's an LS motor, and there's the Mercedes-Benz, and everything else that we could work with. But primarily, the two heads that we're going to work with is this 300 straight 6 Ford engine, or one of the 460s, could be 429 engines. And the reason why we're going to do that is because these are new, rebuildable, damaged castings that have been donated to us for practice purposes to do practice cylinder heads. The thing that you need to remember is, as we just spoke of, lab sheet 3, 4, 5, and 6 are all connected together, so you need to basically, actually even also lab sheet number 9, we'll get there, all go together with one particular head. So it is best if you make sure that you get appropriate size valves to fit a head, pick a cylinder head. Now, this head here especially, these heads were the ones that we had in the hot tank, and yes, I got the steam cleaner working, and after we got it done, the little oiliness is WD, so it's not going to corrode. You can see that there's a little bit more color still to this cylinder head. It hasn't been soda blasted, such as this one, but if we do take a look at the differences in the surface finish, we can see that the heads that have been wheel abraded or tumbled, we can see that these particular cylinder heads do have a much rougher surface. In some instances, these gasket surfaces here, once we get them clean, or a little cleaner than they are, may be reusable. This would have to be surfaced. We would have no option. But there's a difference in environmental impact between the cleaning methods. The thing we need to remember is we need to get a valve that's going to fit this. Now, some of you did these heads already on your spec sheet. You are going to have to find all the specifications for it. The challenge to these particular cylinder heads, and I believe we have an appropriate set of valves, is the fact that there are two different size intake valve head diameters that can fit the same cylinder head. I brought two of them out here. They look pretty much the same. They're basically the same total length. The tip height is the same. The total length is the same. The stem diameter is the same. They both have single keeper grooves on them. But if we put the two heads of the valves together, we do find, if we look at that intersecting part, that they're not the same diameter. They're different diameter valves. And we do need to either, by setting the valve on the intake valve seat and see that it overhangs the seat a small amount, is what we want to see. If we go in here and we set the other valve in place, even though it does cover up the valve seat, it covers up a large portion of it. Now, it isn't the fact that if we had a large valve that we couldn't adapt this valve seat to fit the bigger valve. However, when it comes to hand grinding, you will be in there hand grinding a seat for a while to get enough material out of it to fit the bigger valve in it. So the challenge is to make sure that you have the right size valves for the head to start with. Now, primarily, this is pretty close to a finished valve. That is primarily what your valve should look like when you're done. A nicely ground valve face, something that still resembles a margin, a stem that's been polished and measured, a clean keeper groove. It has been tipped, it has been chamfered, and we're all in good working order. What we started with was probably something that looked like this. Now we start with something that looks like so, right? And we should finish with something that looks like this, as well as all the specs are good, right? So, and then there's also a thing we talked about, face runout. We do know that we will have to measure a couple of things to measure the head diameter. What was the best way to do it? Probably a dial caliper, right? So we would use a dial caliper to come after actual head diameter. It's best to put it on a slight angle like so we get an accurate measurement off of it. We would also, of course, be measuring the valve stem. When we measure the valve stem, what are we supposed to be using? We should be using a 1-inch mic, right? So when we come in here, you know, when we start with a mic, we remember the rules. We need to get a clean sheet of paper, make sure that it zeros. And what we will do is we will measure the stem in multiple locations. Most of the time, when we measure the stem, down here at the bottom, there's sometimes very little wear. And usually, right up here at the top, there's very little wear because it does not actually touch the valve guide. The places where we find the greatest amount of wear usually are through the middle. So when we go in here and we measure it, bless you, and when we go in here and we measure the stem, we will measure it in multiple places and compare the dimensions, and we should also rotate it and check it on several axes, not in various locations just up and down, but around, because sometimes they'll be oval as well as tapered. So what we're looking for is extremely straight after we've polished it. When I ask you to measure length, total length of the valve, or how much material we've removed from the tip, the way the valve grinding machines are set up, it's difficult to really gauge how much we've removed. The better way to see how much we've actually removed is to use our larger electronic caliper and go in, and before we tip the valve, we should measure total length of the valve. And we do the best job that we can in getting it nice and straight, getting the face on here correctly, and getting a good solid measurement as far as how long the valve is. This one happens to be 5 inches, 169 thousandths of an inch. Then we'll tip the valve, and after we've tipped it a small amount, we go back and measure it again, and the difference is how much we've removed, okay? And we do remember that there were specs within the sheet that you should be coming familiar with on how much material you can take off. But remember, when we start, how much do we take off? A very small amount, just enough to clean. Then we chamfer. After we get our seats done and everything else, we may have to go in and tip again. I can take more metal off. I can't put it back on. So if I take too much off to start with, I may louse up my tip height. Even though as I grind the seat in the face of the valve, I will increase tip height because I will be grinding material off of the valve face and off of the valve seat, which will cause the tip to protrude farther into the head, right? Hopefully I don't have to take off too much, right? And remember, after I grind the face is when I've got to see how much margin I've got left. When we talk about using the runout gauge, we have two different valve face runout gauges. We haven't seen these before. We have two different styles. What it does, we talked about it a little bit. We're trying to see how consistent this surface is to the center line of the stem. So either measuring tool will work. We have to have a straight stem to do this. And the reason why we have to have a straight stem to do this is because it actually uses the valve stem itself right in these two locations where these steel balls are, or where this V is, to hold the valve in place. We should usually readjust the stop so we get the stem set about in the middle of the support mechanism. The valve will come in here, and then the challenge becomes adjusting the dial indicator so that the tip of the indicator right here, which is the moving part of the dial, yes, works just like a clock. Yeah? Okay. Should sit about 90 degrees to the face. So it should create a 90-degree angle between the angle of the face of the valve and the tip, and then should be just about in the center of the valve here, so that you get alignment this way through the center of the valve, right? And so you get a straight shot at that face. Then you have a little backward pressure on it, and you rotate it, and you see if the dial indicator moves. Now, if we're real lucky, because each one of these lines is 1/1000th of an inch, right? If we're real lucky and we rotate it, I have less than 1/1000th of an inch movement in that dial indicator. Less than 1/1000th. Under 1/1000th of an inch. So that means I'm down to about less than, yeah, it's definitely a win, right? We're definitely in the preferred range. You know, sheet of paper, good quality paper, is almost 4/1000th of an inch. That's very close to being exactly straight. Okay? If you don't see any movement in the indicator, it just means we need a better dial indicator. I don't have a better dial indicator. That's all I got. Okay? It's as good as we get. If you're in that spec, it's better than probably 50, 60%, or maybe even more of what the machinists actually do. There are a lot of machinists out there who don't even have one of these tools. Should they? Yes, they should. You know, otherwise, that's good. You know, I don't like that. I don't like that. Okay. Actually, there's various different suppliers. There's one that I'll try to get you some catalogs for if you guys want catalogs on all sorts of machine tool parts. This was a couple $100, I think. You know, the dial indicator, because this one actually has a nicer dial indicator on it. But once again, if you take care of this and you treat it like something that you bought, how long is it going to last? Forever. Yeah, basically forever. If you treat it like it's a piece of junk and you don't care, it won't last the morning, right? So we take care of the tools that we've got, okay? So what I should do is I will select, there's finished product, and this one's actually not too dirty, is it? You know, but can the valve itself tell us a story? Yeah, we can look at the condition of the stem. The stem doesn't look too bad. The keeper grooves still look good. The tip is actually relatively smooth and flat. It's got an acceptable chamfer on it. There is no excessive erosion in the face. There is some margin. It's not burnt, and generally it looks like it's probably a rebuildable valve. So what's miles on it, maybe? The carbon? Probably 150 something. Oh yeah, sure. If they're working right, that they don't carbon up a whole bunch. When you start using questionable types of lubricants and bad maintenance schedules, that's when you start having problems or overheating the thing. You know, how'd you take care of it? If you took care of it, this stuff stays together. If you don't maintain it, that's when this stuff usually starts going bad. Water and alcohol would have taken that. It could have, yeah, some of it. This is supposed to be what those fuel injector additives are supposed to remove, is the gunk on here, or prevent it from accumulating in the first place, right? And they work somewhat, okay? You can only scrub so much. And the only thing that's starting to happen, I don't know if we haven't talked about it too much, the new engines that are called direct injection, where they're injecting the fuel directly into the combustion chamber, we're seeing a new problem. These start to carbon up, and they get a little chunky on the top of it, but there's no injector spraying cleaner on top of it because the fuel injector's down in here. So we have a new idea for fuel management, right? Now we're creating a new issue because the valves are starting to carbon up again. They used to in the old school days. Then we changed fuels and got to the point where they keep the top of the valve clean so we wouldn't have a contamination problem and a cold start issue. Now they're moving it down here. Now it's starting to reappear. Nothing is for free. Everything's a balance, okay? So my first step is what? My first step is to clean. So I'm going to make sure that everybody's got safety glasses on, and I'm glad that everybody's wearing safety glasses. The number of times, just get in the habit, right? Because I told you what, you know, you got a job someplace, you hurt yourself without your safety glasses on, they got to fire you, or you'll sue them because they let you work without safety glasses on. Don't follow that path. Yeah? Yes, sir. Thank you. Okay, now we're going to go into the grinding room over here. Going to make those vertically gifted should be in the back, and those vertically challenged should be up front, right? Come on in. Thank you, right? You know, and we can see how clean the bench is. There's a man who trusting in how clean the bench is. Okay, we got a wire wheel here. We're going to clean the carbon off of this, okay? Now, do remember with the wire wheel, there's a couple of rules, right? As well as it also states it right here, eye protection is required. Wire wheels are actually kind of dangerous because they do have little bits of wire on them, yes? Right? Do they come off? Yes. Yeah, and honest to goodness, at some point during class, I don't want to have to take a pair of pliers and try to pull it out of your eye. Okay? That's not what I'm here for, okay? Also, this thing spins and at a pretty good rate. It will do several things quite well. It will remove rust and this carbon deposit rather quickly. It will do that by friction, so it will make the valve hot. It will also, if you get the valve in the wire wheel in the wrong spot, snatch that valve right out of your hand so fast you won't know where it went because 1 minute it'll be there, and all of a sudden, whoop, and it's gone. Where'd it go? It's missing, right? It's down inside the filtration system somewhere, and now you get to go dig for it. The other thing that it will do is it will, at a very rapid rate, remove skin, okay? It is looking for meat. It will create a leak, so you do need to be cautious. The best way to do this is when the wheel is spinning, you should go after and hold the valve at this kind of an angle and push the curvature or the fillet radius into the wire wheel like so, or kind of like this, at this type of an angle, keeping the leading part of the valve away from the wire wheel. If for some reason you seem to be under the impression that this would be a good idea, to go after it this way, what it will do is the edge of this will get caught in the wires and it'll snatch it right out of your grip. And if you're lucky, it winds up in the machine. If it doesn't, it's going to eject it somewhere out into the grinding room where you're standing and some of the other students, right? So you need to be cautious. You also need to put a pretty good amount of pressure up against it, and do remember it is friction, so it will get hot. And usually what we should do is go in and very lightly kind of clean just the keeper groove area, right, with the wire wheel. So what we're going to do, we're going to pick the side that's got a little cleaner glass on it, right? Well, it is a little farther away than it should be, so it should probably get a little bit of maintenance, and that's a good point that was made. But it is a wire wheel and not a grinder, so there's a little bit more leniency there. So what we're going to do is we're going to come over here, and of course, since it's got a big blower on it, it's hard to hear much of anything when it's running, but we'll start it up. It's burned oil. What do you want? Then I do need to clean the head. But once again, it's the rule of putting it into the wire wheel like this, not like this. Don't let the wires try to grab a hold of the top. Voila! C'est magnifique, hein? Oui, monsieur. Now, I didn't actually go in here. I should probably just touch the top of this. I think within our text it says don't wire wheel this whole section. We just want to be able to clean the keeper groove. Definitely a much shorter operation. Are there other ways to clean this? Yes. There are all sorts of various ways. This is the procedure we use here. There's tumblers, there's wheelabrators. If you use a tumbler or wheelabrator, they actually have to put a rubber protector over the stem so that you don't beat the heck out of it. Now what we're going to do is we're going to polish the stem. Because now this actually feels like it's pretty doggone straight, but it does have some little bit of personality, some small slight chafing in the side of it. So what we're going to do is we're going to go over to the lathe and we're going to polish the stem. So we're going to go over to the lathe now.
What is that valve? It looks easy, but it's scary. It looks scary.
12, 15 bucks. Okay, a lathe, actually referred to as an engine lathe, right? Now, a couple of things we're going to need. Remember, we had a little piece of emery cloth, so we'll wind up with a little piece of emery cloth, which we're going to use, okay? Now, I don't know if anybody here has used a lathe, but one of the options that you have for classes is machine shop, right? And in machine shop, you wind up using a lathe. It's a multi-purpose tool. It'll do all sorts of things. We use this. One of the things we use this for is polishing cranks, polishing valve stems, things like that. There are some general rules. Probably one of the most important ones, this is what we call a chuck, which rotates. Things to watch out for, sharp corners. Once again, there's a lot of things around here you can get hurt on, right? If you remember the basic rule, besides making sure that you usually should always wear safety glasses, usually it's a good idea to wear gloves. However, usually on parts with rotating components like the wire wheel and this, it's debatable whether you should wear a glove. Some people say you should wear gloves if you're working in the cold and you're using a circular saw in building construction. However, OSHA says no, because what can happen is the glove can get caught. And if the glove gets caught in a rotating part, it's going to suck your hand in right along with it. So chemicals, yeah, you should wear gloves. Usually rotating parts and things, you have to be very cautious. So what we're going to do is we're going to adjust these jaws to grab a hold of the head of the valve. Now the challenge in here becomes how well can you align this? Now some people will take it and just set the valve all the way into the base of the chuck like this and it'll hold it out straight. However, if you try to polish the inner end of the valve down in here, the inner part of the stem, your fingers are going to be too close to these pieces which are spinning. And you do not, trust me, you do not want your fingers to come in contact with these sharp metal corners as it spins, okay? It'll make a bad noise and it'll hurt, right? From experience, don't do it. It hurts, okay? Okay, good. You don't necessarily have to practice everything. What were you practicing? Oh, how to get my hand stuck in a lathe? Oh, yeah. Bad idea. Okay, now, what I do here to try to make sure that it's straight is I sight off of one edge of the valve and I pick a straight edge, like the back edge of this way. And I kind of look at I move my head till I get a pretty good horizon line and I can see where it's in alignment, and then I'll move it and see if it stays pretty straight. And when it's there, I'll give it a little snug. Now the problem is, if I get out here and yank on this thing really hard, I will actually distort the head of the valve. I can crush the thing, right? So what I do is I snug it enough so it'll stay in place, not come flying out of the machine when it's spinning, and not so tight as to the fact it distorts the valve. But you will notice that the biggest rule, this is a chuck key, okay? The chuck key goes in to open and close the chuck. The rule is, if the chuck key is in the chuck, your hand is on the end of the chuck key. As soon as you're done, it gets set to the side. Never, ever even think of doing something as dangerous and as death-defying as that. Okay? Well, and you laugh.
Why it happened?
Well, because somebody's going to leave this laying in here. And are we notorious button pushers and knob turners? Yeah. We all are, right? And this thing is going to be sitting in the end of that chuck, and somebody's going to come over here and do that. Guess where a chuck key is? Sticking out of somebody's forehead.
We don't need that.
No.
We don't want that.
No, we don't even want to think about that. So the rule is, when you're making an adjustment, that's fine. Just keep your hand on it, otherwise set it aside. Okay? Now, safety denotes that what we should do is polish the stem this way. That is the safest way to do this. I will be a daredevil. I am going to actually wrap the piece of emery cloth around it and polish it this way. Now, the reason why they say that is usually not a good idea is because what may happen is this emery cloth may double over on each other and wrap up into the valve stem and start spinning with the stem. So now the problem is if I were to polish this way, right, I could be here for a while waiting for it to polish the stem, right? I'm going to try to get this done. So, as a compromise, if I am going to use this method to polish the stem, I will remember to have a dainty grip, right, on the end of this emery cloth. No death grip, right? You wind up with the C-clamp vice grip, you know, I'm holding on to this no matter what, and next thing you know, you're going to be trying to polish your hand in the lathe, okay? We don't want to do that. So we're going to turn on. Now, it'll rotate this direction, or it will rotate towards you. And usually you want it rotating towards you, okay? So what we're going to do is just come in. No oil, no need for oil. And we leave a little bit of material behind on the emery cloth, and sometimes actually the emery cloth that's a little used will sometimes even make it look a little nicer, because this is 400 grit emery cloth, which is about the right grit, which is pretty smooth. And what we basically have is now we have a clean polished stem. Now we've still got some minor little scratches or deviations in the side. Could be from the way it was disassembled. But if we actually feel it, it's very, very smooth, and there is a very light crosshatch pattern or X's in it. That's what we want to see. We just don't want to see swirly lines. We want to see a crosshatch pattern. But that means that primarily I've got a pretty straight stem, and usually it also gives me a chance. I can kind of look at the luster on it. You can see where the guide was wearing for sure, right? So you know kind of where your wear patterns may be, but you don't see any major deviations in the way the light is being refracted off of it, which usually tells you it's pretty straight to start with. Okay, so now I'm cleaned and I've polished my stem, yes? So now what do I need to do? The next step is to measure the stem, right? Because I've got to check it for taper, because it's got too much taper in it. Guess what? What are we going to do? New valve, yeah. Like the umpire says, what?
You're out of here.
You're out of here, right? Okay. And so we're going to go over and grab a hold of a micrometer.
Can we throw sand?
No. Don't throw sand.
No sand?
And don't kick sand on the umpire's shoes either, right? Right? So now what we're going to do is we're going to go in here and we're going to measure our valve stem. I'm going to measure down here, right? And we have 341, 341.6, 0.3416. Okay, it wasn't clean before, so I really shouldn't measure it, right? Because there could have been schmutz on it, and we don't want to go and measure that, right? And right here I've got 341.7, right? And I come up here and I can look again. And I got 341.6. I'll look at it on another axis in a couple of spots. $341.7. Try to look maybe in a high wear area, which is usually at the ends or at the extremities of the valve guide rub area. $341.7. Down here where I probably have got my biggest wear issue, 341.5. What's my taper?
1 or 2 tenths.
1 or 2 tenths of 1/1000th of an inch. Good or bad?
Good.
It's a keeper, right? So the stem's good. I'm also going to kind of look at a basic visual inspection of the keeper groove, right? So now my next step is I'm going to grind the face of the valve. Now, to grind the face of the valve, we know that usually for most of these seats, we're going to cut the valve seat at 45 degrees. Yes? That's what our stones are set at. That's what our cutters are set at. So that's what we're going to grind the seat at. Now, if we're going to grind the seat at 45, what do we want to grind the face to? Usually we want to have somewhere between a half to 1 degree interference. Some manufacturers will tell you that they should be exactly the same angle. Most of the time we put an interference angle into it, and I will normally, especially for during starting to learn how to grind seats, I will recommend that you put a 1 degree interference in it. Now that means that there's a 1 degree difference between the two angles, right? One's going to have a smaller angle. Which one has the smaller angle? The seat or the face of the valve? If you get confused, what's the easy way to remember?
45.
Well, looking at this one valve versus this entire head, which part is smaller? The valve gets a smaller angle. Smaller part, smaller angle. Bigger part, bigger angle, right? So what we're going to do is we're going to go in here and we should grind this face probably somewhere between 44 to 44 and a half degrees. What we will do is we'll grind it to 44 degrees, and what that will do is that will give us that interference angle. If you remember from the handout, it'll give us a little bit of change in angle here. And when we start grinding seats and we start looking for overhang and contact points and all the rest of this stuff, it will be your friend, okay? Because it'll give a real good indicator. Okay, we have 3 valve grinders. We have an old New Way machine, which actually works quite well. This thing was probably bought about 1972, okay? And to tell you the honest truth, it'll hold a very tight specification. We have a newer design quick way machine here with an air-operated ball chuck on it. This one has a hand-operated chuck. It is the one that you will use during the hands-on final. When I say it has a hand-operated chuck, this is what I'm talking about. This particular lever right here opens and closes the chuck, which is where the valve goes. We've got this one that's got an air-operated chuck, which needs a little bit of TLC, but we'll get that handled. And then we have the other design, which is actually, I think, a better design tool, but unfortunately, Sioux Tools is no longer in business. But I actually think it's a better valve grinder. This is a very old, steadfast component. You will find it in a lot of shops, and it will hold a very tight tolerance. This one I kind of like a little better. This particular chuck, kind of along the thought of the steel balls here, this has what they call a ball chuck in it. And there's sets of 3 steel balls that actually go in and grab a hold of the stem. That's good, but it's grabbing in 3 spots. Is there a better method? Yeah, there is a better method, and it's usually what they refer to as a collet. These are actually collets, and it's a serrated piece of metal that fits into a taper that the valve stem actually goes into. Now, this one's a little larger than what it needs to be because it's not the right size for these stems, but what it does is it goes in, and then the taper grabs a hold of the stem. Now, this is why we need to make sure that the stem is good, because what do we do to indicate and to grind the face? We hold the stem. So if the stem is bad and it's got too much taper in it, do I know where center is? No, right? So I do need a good stem. So here's what we do on this particular machine. Plus, I think one of the things that's kind of good is the fact that the machine actually has, the grinding action happens out on the front. It's a little easier to see. Now, we come in here, and with this button, basically we get this air-operated chuck, and we'll have to probably demonstrate this a couple of times. It's kind of hard to see. We see the chuck moving back and forth?
Yes, I do.
All you people who bought the inexpensive seats are now wishing you bought the better ones, right? Because you'd be able to see what was going on, okay? But that action right there, yeah, and that could be worth just that. The stem will actually, the valve should, whoops. The valve should be able to go into the chuck, and then the way it's set right now is, notice that the valve kind of falls all the way in here. That's a bad idea, right? We don't want it all the way in, because Do remember, on this part of the stem up in here, there's a lump, yeah? Right? We don't want to be grabbing the lump. So what we need to grab very quickly is the adjuster. We go into the back. There's a stop in it. We'll pull the stop forward. Now when I take the chuck and release it, and I push the valve into it, now it's sticking out just a little bit too far. Okay? That's going to be a mess. If I have the valve sticking out too far and I've got a little deviation, the valve's going to kind of do this as it spins. So I do want to chuck up on it about here. Not too far up, right? Not too far out. We take it and we push against the stop until we get a little bit of the valve head and the stem sticking out of the chuck. That's kind of where we want it. We do need to check and make sure that it is tight enough. If we can turn the valve by hand, we need to tighten this chuck a little more, and we'll adjust the air pressure on the regulator here to give it a little bit more oomph. When you get to the point where you can just about turn the chuck with the head of the valve, it's adequately snug to hold it in place. Now, I did say that we wanted to adjust the angle. This knob up on top, if we loosen it, we can actually take this entire assembly and swivel it back and forth. We have a little scale down here on the bottom of the machine where we've got 44, a line, and a 46. Guess what those lines denote? The angle, right? So I got a chance of either setting it anywhere from 46 to 45 to 44, right? So what I'm going to do is I'm going to line the edge of the machine up here with, we'll say, the 44 degrees right there. Then I'm going to come in here and tighten that. Now, notice I just snugged it down, right? You don't have to over-tighten it, okay? It just needs to be snug. Now, what's going to happen here is now we're going to run our grinding wheel, and actually this thing's got a huge groove in it right now, so I need to what we call dress the stone. So we're going to dress the stone first. We're going to make sure that both of our oil supplies are off. And I'm going to take the truing device over here and adjust it so that I can true the face of the stone. As I move this lever here, the stone will, this carriage assembly will traverse back and forth across the face. And I want to set it up so I can get, there's a little diamond in the end of that. So it'll go in and actually dress the face of the stone nice and flat. Now normally we don't have to do this with every single valve, right? But when we start seeing either a line on it or we start having a problem with run out on the face of the valve, we could very easily have an issue going on with this. Depending upon the type of valve grinding machine, this one happens to center just on the stem itself. Some machines actually use the chamfer on the tip of the valve. Our valve instructions say to actually tip and chamfer before you grind the face, but on this machine it's not as crucial and you can do it as a secondary operation. So we're adapting to the type of machine. So a little deviation in that. But we're going to check the stone to make sure we can get the stone dressed up nicely. Get the stone running. We're going to turn this hand here. Now, there's a protrusion off the crank handle here, right? And we have a great tendency to go in here and start using the crank handle, right? Because we are notorious, right, turners of things, yeah? However, do we get real accurate control with this? No. So what we're going to do is we're going to bring it up so that we get pretty close. And then what we want to do is grab the outside edge. Because we get better control. I don't want to crash anything into the stone. Just taking material off of both sides and not in the middle, right? Now, some people will say that when you get the stone dressed and you get a nice smooth cut all the way across, you should go back and forth across it several times to make sure you got it really smooth. if you listen to the people who run precision grinding centers, and I do have a machine shop background, it is better to run the dressing tool across it once to expose the sharp granules, because it'll cut better and generate less heat. If you go back and forth across it, it will make it smoother, but what it will do is it will take the sharp portions of the crystals that are sticking out there and it'll flatten them out. So instead of cutting, what's it going to do? Just try to polish, and all it'll do is make a bunch of heat. And sometimes we wind up with a zebra stripe pattern across the face of the valve. So what we're going to do is we're going to go in here and make sure we got our last pass, which should be coming out. We'll just a little bit, and we'll make one nice smooth move. Right across the face, and we're done. Before we go adjusting anything, you should always make sure the machine comes to a stop. Once it's come to a stop, we'll move the dressing tool out of the way. Now we're going to go in and we want to set ourselves up initially. Now notice how the valve's going to run into the side of the stone. Bad idea. Now this is where we would use that end, right? We kind of get ourselves relatively close so that we know we're kind of set up. Now we also don't want to run the face of the valve, the 45-degree angle or 44-degree angle, off of either side of the stone. We want to stay in the middle. We don't want to fall off an edge. So we do need to control the way it works. Now, we also don't want to go too far in. If we go too far in, we may actually grind a notch in the edge of either the fillet radius or the stem. And if we grind a notch, guess what? We need a new valve, right? So what we're going to do is we're going to come in here, and there is a stop. Now, as crazy as it is going to look like a magic act, down here, underneath this, there's an adjustable stop. So if we adjust the stop, I can get it to the point where I can't even get onto the stone. What I want to do is I want to adjust the stop here with my left hand so that we've got a pretty good cross or sweep across the face of the stone. As I'm grinding, I want to move it back and forth this way. I usually just don't hold it in one place. Okay, questions? We good? We're on. Then what we need to do is we need to get our coolant going the right direction. We're going to start the chuck as well. There is on this one adjustable speed for how fast the valve spins. Anywhere from really quick to pretty doggone slow, and the bigger the valve, the slower you want it to rotate. So what we do is we're going to slow it down a pretty good amount, right about here, because that's a pretty good sized valve. If I ran a dinky valve, a small valve, right, I would run it at a higher rotational speed. Now what I want is I want some coolant flowing across it. Okay, so now I got coolant going across it. I'm going to bring it up into position, and now what I've got to do is I've got to slowly start bringing the stone up to the face of the valve. And this is where I usually want to use the outer part of the wheel. Always make sure you're turning it the right direction. Yeah. Right? And normally you'd be standing completely in front of it, right? But I'm keeping the face moving across the stone. And eventually, now here how it's a partial grind, right? As I'm looking at it, I can kind of see a couple of stripes. And what I want to do is I don't want to advance it too far in there too quickly. I'm getting a more solid pattern, and I'm getting a more consistent finish because I can see the edge of the face of the valve. And then I want it to what they call spark out. Here it's not cutting as much, right? Then what I want to do is I'm going to come in and about 2 turns back the stone away from it. Then I can move the valve off of the face, okay? I don't want to slide the face of the valve off the edge of the stone while it's grinding. Because odds are that stone's going to start getting a little bit of personality to it, and the edges of it, because we don't want to fall off the edge, may be a little higher. And over a period of time, as you saw when we first dressed it, that stone gets a little high edge on the side, and if I pull the face of the valve over, it puts a swirly in it. And you take a look at the valve and you can see a little swirl pattern of where that high edge of the stone cut a little groove around the edge, right? Now that I've got it out, I grab a shop towel, I push on the end of the button, and it sticks a little bit sometimes depending upon how much it's been used. I get the valve out, and then what I should be able to do is wipe the face off. And what I should have is a nice, smooth, clean, high luster type finish. Not shiny, not striped, no bars, no dips, no holidays, just a nice ground, kind of a burnished silver finish. That's what I'm looking for, right?
Does that machine does a pre-face more intricate?
Most of the time you grind the face of a valve just on a single angle. It's the seat, you do multiple. Usually the face of the valve just gets one angle. So now what I do need to do is I should dress up the tip and the chamfer, yes? Sometimes I have to do that first, depends upon the machine. They sometimes say you should do that before. On this machine we can do it afterwards. That's done over here on this side of the machine. And an adapter here for the chamfer. We've got a stone in here in the end. There's a place for the valve to fit in there. We'll come up close to the stone. And what we want to do is we want to get the valve relatively close to the stone, but not touching it as yet. And then there's an adjustment back here in the end, the knurled handle, right? I didn't actually record, well, I didn't write down the number. We did come after the dimension before, which I should have recorded on my lab sheet, yes? Yeah. And what I need to do is I'll move, same process, gradually adjusting. And with luck, I've got a nice flat surface on the tip of the valve. I didn't have to take much material off at all, right? Now I do need to do a chamfer. Even though this chamfer looks pretty good, I do need to do a chamfer. Now there's an adapter, which is this piece right here. And what it does is it holds the valve. This fits into the clamp. It holds the valve and it has a stop in it. And what it does is it allows you to rotate the valve so we can put a chamfer on the end of it. Some people do them by hand. This does a nice job. Now I have to admit, there's a lot of adjustment in here, but normally if you're doing a cylinder head or a pair of heads, you'd be doing 8. If it was a V8, we'll say you'd probably be doing at least 8 intakes and 8 exhaust valves, or you could be doing 16 intake valves, 16 exhaust valves if it's a 4-valve motor. So what you do is you'd set up to do one, and you do all of the intakes in this operation, you do all the exhausts in this operation, so you don't reset the machine every time. This is how we do a chamfer. We put the adapter in the machine, which will hold it on an angle like so, and turn the grinder back on, bring it in here, we listen. Where is it? Where is it? Oh, there it is. I'm lightly pushing downward to keep it up against the stop. And what I make is a nice little 45-degree chamfer right on the edge of the valve, right? And the one nice thing about this machine is the fact that once you get it set, if you're chamfering, and you set that for your spec, because we all remember what that was. What was the width of the chamfer? 1/64 to 1/32. And of course, as we all remember, 1/32 is also 31 thousandths of an inch, and 1/64 is basically 15 thousandths. So we're between 15 to 30 thousandths width, right? Once we get that set correctly, if we don't move anything, we will repeat that width consistently on all the valves, right? It does save time in the long run. Now, last but not least, basically two last things to do. Now we're going to see if we're any good at this, right? Okay. I'm going to put it back into the indicator, set up properly. We can keep our fingers crossed. And I'm under 1/1000th of an inch. Okay? So to show you that it isn't magic, it isn't smoke, it isn't mirrors, it can be done with the equipment that we've got here on a used valve. Okay? Now, the only thing that we would then have to check eventually would be, one of our critical things is going to be margin thickness, right? Now, generally, if we remember, we were supposed to be somewhere in about a 32nd of an inch. That's probably not a 32nd of an inch. Some valves do vary, so we may have to check for it. It's an intake, so it can be a little thinner. If we do wind up grinding a whole bunch off the face, what happens to margin? It continues to decrease until we wind up with, as I refer to it, when this turns into a sharp edge, only thing you can do with it is cut pizza, okay? Can't use it as a valve anymore because it'll overheat and burn. But that's basically what we've got. That's a valve that's pretty much completely reconditioned. The tip's done, the chamfer's done, the keeper grooves are good, we've cleaned, we've polished, we've ground the face, we've obtained our specification for its taper, we've got good run out and a good surface finish on the face of the valve. Hopefully our margin is still within specifications, and we got a valve that's ready to go. There, that valve gets to run again. If it failed any one of those steps, put a new valve in. If a bunch of them get to the point where they're all starting to fail, guess what you need to do? You just need a set of valves. Don't mess around. Don't sweat. Oh, but you could save. No. Saving nickels and dimes is not going to be worth it. It's not nickels and dimes, but when you look at the cost of some valves versus the cost of a complete engine, you get a valve failure, it can cost you a complete engine. So we're looking at maybe a couple $100 for a set of valves versus a couple of $1,000s for a replacement engine. Which is the better choice? Well, we'll go to committee and find out what's best, but I'd probably push for putting some new valves in, okay? So that's our lab sheet 3. Questions? That's it. That valve's ready to go.
Did you recheck that for 45?
Oh, not only, well, we know that the angle's correct. The only thing we didn't do that we should have done, right, was to check our total length. I can't remember what the heck our length was because I didn't write it down, yeah? Were we supposed to? Yeah. Said in the instructions we were supposed to, right? 5.163. What was it before? 67? 64? So we only took a couple of thousandths of an inch off at the most, right? And that's about where we need to be, okay? Now, we may need to do an adjustment later, but that's what we need to do initially, okay? Then we know how much we took off, okay? There's lab sheet number 3. Okay? You got it.